Okay. Close it up. There you go. How you doing?
Hey, Armando, are you there? Okay, so he might not be on the phone. He might be in here, but he can hear us through the speaker, through the broadcasting.
Oh, you might. Did I start broadcasting? Okay. Let's make sure this stuff works.
Audio.
Stop audio, internet audio broadcasting. Right?
Yeah, we got it here. Should be started. So yeah, see it is. Yeah. Hey.
Okay.
And Paul's in here too, so.
It's me.
No, that's you. First time on the deal. All right, so we're all here.
Okay.
But Armando can't hear us. He must be on a computer connection.
So what do I do? Share the application?
No, he can see.
Yeah, but I gotta bring up the checker application. Or do I want to talk about the brochure first?
Let's talk about the brochure first.
All right, Armando. I think you're the only one here so far. What we're going to do is we're going to talk about the application brochure, just a few things that we can do with the Checker product. I'm going to pull that up right now. How do I share it? Oh, that's already right there. That's the brochure. Because I don't have that brochure up. This is from yesterday.
Oh, you don't have the brochure up on your laptop?
No, I don't.
Okay, bring that up first. Sure.
Alright, a couple technical difficulties here. The brochure should come up in a matter of a couple seconds. And these are some of the applications of what you can do with Checker. This brochure is available on our website, www.cognex.com, under Checker product, and then should be under PDFs. So go down here, scroll down at the top here, you see the Checker product. And then you see a couple applications right here. This one's verifying that the cap is present. Also, a date lot code is present on a milk jug. Some presence-absence application. The Checker product is a presence-absence sensor. Just basically trying to see if something's there or not. It's not going to do any OCR or any measurement or anything like that. It's just a presence-absence sensor. There's a couple more down here. As we scroll down, we'll see some more applications. This one right here is a O-ring that's on a headlight bulb, making sure that that O-ring is present. Very difficult thing to do with traditional sensors, but as you can see, the Checker product does it very effectively and in a cost-effective manner. Also, it's a relatively easy application to solve with just two contrast sensors placed on the place of where the O-ring is, and you'll learn more about that as we get into training on how to do this, and you'll see just how simple this is. Go down to another application. This is packs of gum. Traditionally, with standard sensors, you'd have to have 12 sensors to do this application, and you can do this application with just one checker. That's 12 sensors with 12 I/O paths, cords, and an array of power and the labor that goes along with it. Much more cost-effective way of doing this is just simply with one checker. The real estate involved in a panel is much less and a lot less programming. We're going to go down to some more applications. We're just going to go through this brochure kind of quick here to give you an idea of some of the purposes that the Checker product, some of the applications we saw. Right here is a paint dot, just on a paint dot on a flywheel of an engine for when they rotate the flywheel, so that they can tell where to put the balancing weight. Right here is an assembly like a nasal spray bottle, verifying that the flow control insert is placed in the bottle. Difficult thing to do with a photoelectric or a laser. Relatively simple thing to do with a checker. One pattern sensor and you got it. Go on down here to the automotive industry. This is thread detection. And this is what I'm going to be demonstrating today. I have some 6 pieces of steel that are placed on a turntable. Some holes are threaded and some aren't. And this application is the one that, like I said, is the one I'm going to demonstrate today, and just how easy it is. A very difficult thing to do with lasers, especially if they move. You can do it, absolutely, but if the part moves or varies in a way, the laser beam doesn't like it. Cheaper to do than something called an eddy current probe, which in this particular application we replaced the eddy current probes that were being used with checkers. I can't tell you if that thread is good or not, but I can tell you that somebody made an attempt to tap it. We're going to go on down here to a safety seal. This is a double inspection. We're going to make sure that the cap is on and that it actually has the safety seal present on this. This is a nasal spray bottle for this application, pharmaceutical. Go on down. I think we're about done. This is another automotive part. This is one of my personal favorites, being I came from the automotive industry. The weld nut. This is looks like on a axle tube. Very difficult thing to detect because it's inside of another area. Trying to detect this with a proc switch because it's encased in another U-shaped piece of steel is very difficult to do, and the checker does it very well. Another multiple sensor product inspection, and this looks like pop bottles or bottles in a box, making sure the package is full before they close the flaps. There's another application that goes along with this. Before they close the flaps, they make sure that the flaps are closed, but it's just not illustrated in this brochure. Next application, we're looking at O-rings and a seal on a fuel line, making sure that they're present so that they don't get damaged, and then it can cause you fuel leaks when it gets assembled. And here's some more stuff about the checker. Fast operation. No external trigger required, some bullet points about the product. So why don't we get started and actually demonstrate how the product is being used. Go over here to the checker. What you see coming up on your screen now is the Checkmate software. This is the software used to configure the checker. And there's an image here. It's kind of a little fuzzy, but because I haven't done any adjustments yet. And I'm going to move the mouse around and point to various segments of the screen and telling exactly what the checker product, how the software is laid out for the checker product. You see up in the upper left-hand corner here, we have connected to turntable checker. This name can be changed to anything. The default is actually a serial number that's on the back of the checker. Mode, we're in setup, and part detected, no, because we haven't told it what a part was. And we're going to go down here to the getting started, being step number 1, and 4 being run. So there's 4 easy steps, and below every step here, you're going to see a couple sub-steps. And these are the steps that actually go configured for getting started. You set up the camera in. As I change these steps, over on the right-hand side here, you're going to see the frequently asked questions change. So I'm going to select job, and the frequently asked questions are going to change to answer, what is the job? Now down here, right below the image, you're going to see the instructions that go along with each step. So it kind of software's kind of laid out in a U-shaped manner. This tells you where you're at. This gives you instructions, and this gives you help. And in the center here shows you what you're working on. So let's get started here and click Create a New Job. It's going to ask us a couple simple, easy questions. You got to tell the checker kind of how fast you're going to see the product. And in this case, this turntable I got really moves pretty good, so I'm going to kick this up to about 167. That sounds right. And the plane in which it's moving is on a horizontal plane. It's kind of an arc, but it is in fact a horizontal plane. So we're going to go on to our next step there. Then what we got to do is it's asking us the field of view. And the way we do this is with the Checker product comes with a tri-fold manual. And right on the back of the instruction manual, there we include a ruler. You just simply take the ruler and place it in front of the checker. And it looks to me like it's about 3 inches. So that's set up fine. And you can change the inches to millimeters if that makes you feel more comfortable. And you can take the slide bar here, and this is how you adjust the lighting. One simple control. You raise it up, and the image will brighten up. That looks pretty good. Go to a part that doesn't have any threads. You can see the blaze here that comes on the part that has threads, and the one that doesn't is here, and that one doesn't have any. So put that back to a part that does have threads. Go on to our next step here. There's a sub-step saying exactly detect my part. I'm going to select the part trigger. Internal part trigger, what that does is that lets you draw a box around a unique feature of the part that's present in its good and bad parts. The whole purpose of this step here is just to detect the part. Okay? External trigger is going to pulse a bit, and then it tells the checker when to take a picture. Internal trigger is it's taking pictures all the time. In free running mode, we can go back to that because it's a lot easier to show you than it is to tell you about it. What that does is basically hold the outputs on as long as it sees an object in front of the camera, and if it passes the inspection, the outputs will stay on for as long as that sits there. It's designed to replace standard sensors like proc switches and lasers that function in much of like the same manner. I'm going to go on to the next step. It says create a part finding sensor. Click on create a part finding sensor. You should get a yellow box right below that, and that lets you know that you have a part find sensor being created. And you go highlight in the field of view screen here, and you see a yellow crosshair. So you kind of place that on the area in which you want to draw your box. And I'm going to draw this box around the entire top of this piece of steel. And what that's going to do is that's going to tell me that that part is there all the time. Now I want to bring my window down just a little bit because I don't want my part find sensor to detect the outer portion of my turntable. And then I'm going to test my part find sensor. I'm going to rotate my turntable till I see a part. This one has no holes and it detected it just fine. And this one has no threads and it detected it just fine. Because we're not looking at that point right now. We're just trying to detect the part. I want you to notice something here. You see how when I move the turntable, the part find sensor tracks the part? Because what's happening is it's looking for this kind of like a most wanted picture. See this thing right here? What that is saying, hey, I'm looking for this someplace in this box here. And this meter here is telling me how much this looks like this inside this search region. And then you can set this according to how much you want it to look like. Like this is about 25%, 50, 75, and then 100. I like to keep it right about here to account for variability and light changes and surface differences in a piece of steel. But that'll work pretty good for what we're trying to do. We'll go on to our next step. This is a sub-step saying what's happening in the next step. This kind of a subheader here. We have 3 tools. These are actually our inspection sensors. What these are going to do is these are going to tell us, allows us to do inspections to see if that hole has been threaded or if a feature is present. Now, brightness sensors, you can use a brightness sensor on this, but for what I want to do is I'm going to use a contrast sensor. A contrast sensor is a sensor in which tells you the amount of contrast present in a specific area. If it was all black, there's no contrast. If it's all white, there's no contrast. You must have light and dark. And this can be illustrated right over here in our frequently asked questions. You click on this, and a tutorial drops down explaining exactly what I just said, probably in a much better manner. So that keep in mind that the frequently asked questions are actually very well written, and they're there to help. Brightness sensors are exactly what they say they are. They determine how bright that pixel is within a certain region. They're more absolute than contrast sensors. They don't handle variability as well, but they work really well on a lot of incidents. And they have a specific purpose for a lot of different applications where contrast sensors may not work or are feasible. A pattern match is exactly what it says. It's very similar to the part find sensor. Here I have I highlighted the brightness. Very similar to the part find sensor here, and works in much of the same manner. Patterns are absolute. They like consistency, and if there's a lot of variability in your line, I would probably steer away from the pattern sensor unless you're looking for things like holes, which are ultra consistent. They're round. So, do an inspection here. I'm going to grab a contrast sensor. You simply highlight the tool, click on the tool, and you get a yellow box again. And then you can move that up to the screen, and you see how you have a light and dark region next to my mouse pointer. That illustrates that's telling me that I have a contrast tool selected. Or point the arrow on an object, and it throws down a tool for me. Now, for that sensor, opens up a series of tools that go with that specific sensor. I can name this sensor. It says the default is contrast 1. I'm going to name this sensor just because I want to show that we can name it. Now, if I went up to this sensor here, now it says sensor. Go back to this, highlight on the outside edge, and I get my tools adjustments up again. We give you the ability to change from a circle to a rectangle, and that's what I'm going to do. You go on the outside corner, and you can move the region around. When you get the 4 opposing arrows, that's allowing you to move the entire sensor. When you want to adjust it again, you get the 2 opposing arrows in the corner, and that'll allow you to adjust the size of the window. So I got it pretty much where I want it. Now I'm going to go over here to adjust the sensitivity. Now you adjust that up to being more sensitive or less sensitive. What you want to do is you want to make sure that this thing is adjusted to the point where it's just bobbing at about 100% here. You don't want it too sensitive because that's really similar to turning the gain all the way up on a photo eye. It's always on. Adjust my threshold a little bit here. This is the adjustment in which will tell me how much I want it to pass by. So I'm going to go to a hole that doesn't have threads, and it's very low on the contrast meter, and is actually a very robust inspection. general rule of thumb, you want about an inch on the meter, about 25% or one of these segments between good and bad at least. So you can keep placing tools and moving the sensors around so you get that 25% or one region of difference between good and bad. Now, if I wanted this to pass, I could simply move my slide bar down all the way like that, and you can see how the green arrow says pass, but that's not what I'm trying to do. I'm trying to make sure that those threads are present, and so I need to keep this up to about here. Go back to an area in which it's threaded, move my turntable, and you can see that the part detects it. Also, what I wanted to illustrate is you see how the virtual sensor, the inspection sensor that I placed on the part there is tracked by the part find sensor. Now in Vision, that takes a lot of programming to get that to be done, but the Checker, it's done very automatic for you. It's done simply. Now that we have our inspection sensor done and placed on our part, and it works on good and bad parts, we're done with the inspection part detection portion of our Checker segment here. And I'm going to go on to the next step. Highlight that like that. That works. Go on to our next step. And this is the run phase. This is another one of the Checker sub-steps that just explain what's up and coming. Go on to the next step. This is the text function. What this will allow me to do, this will allow me to test the job without firing any outputs. So that, say you got the thing wired up, you're not going to reject the entire free world with just trying to run your job. The outputs are stagnant, and this allows you to see what kind of variability you have in your system. This is the record function, and I'm going to go back to this because this is a very unique feature of the Checker, and I think is probably one of the most important. So we're going to go back to that because it's pretty important. Our next step is setting up our outputs. Checker has two discrete outputs. Can be configured one of four ways, and that's done by this drop-down window here. One is disabled, two, part detect, pass, or fail. Now you can have any one of these configured any way you want. It all depends on your personal preference. You can have two passes, two fails, two detects, or one of any combination you want. So I want to do pass and detect. This is the delay. It's standard at 100 milliseconds. The reason mine says counts is because I'm using the Checker 101E, and what that is encoder. You can see over here how they have a number right here, and what that is it's receiving an encoder that's located in the bottom of my turntable, and as I rotate this, you can see how the counts raise. If it goes the other way, how the counts lower. This is done and used primarily on things like conveyors. A bottle will come in looking for a cap to be present, absent. A bottle will come in and it'll have no cap. The checker will say reject or failed, and the output will be delayed upon counts. You can set up the amount of counts that you want to happen so that when the conveyor goes on down the line, it fires a cylinder at that specific number of counts to reject the bottle off the line. It'll work the same way as if you did it in time, as long as you have a very consistent conveyor. But if that conveyor is sped up or reduced in speed, the time delay would have to be changed. The other portion of the output setup is duration. You can have these outputs on for a maximum of 10 seconds and as few as 1 millisecond. So we give you a pretty wide range of duration to help you with some of them scan time issues. Go on to our next step here. Click Next. Now you can save the current job to the Checker. You can save the current job to a PC, or you can make changes and resave the current job to the job in which you're working on. That's what the save the current job is. So we're going to go on to our next step here. And you're going to see a drop-down window. Now, this is another one of them recording features that I was telling you about. Now, what this does here is I got it selected on my most recent parts. What that's going to do is it's going to record 159 images right inside the checker without the use of a PC, and it's going to show me those images down here on something we call a film strip. While this thing is running, it'll record good and bad parts. Now we have an option of a drop-down window here to record most recent parts, the most recent parts pass, the most recent parts fail. Now down here, this is something that we've installed, the weakest detected, the weakest pass, and the weakest fail. What I mean by weakest is you only get 159, but it'll automatically rank them weakest. So if you run 2,000, it'll keep 159 of the weakest detected parts. Where right here, these are the ones that you really care about, the weakest pass, the ones that were closest to failing, or the weakest fail, the ones that were closest to passing. Those are the two that can really help you in trying to reduce or remove the variability in the manufacturing process. I'm going to select most recent so that we can illustrate good and bad parts in the film strip. I'm going to click Run My Job, and the window changes. And I'm going to turn on the checker turntable here to start detecting parts. About half as fast as I can go. We can go 60 parts a second, and this is at 29.9 parts a second. Turn this down here, and I'm going to hit exit run mode. And you're going to watch when I hit exit, some images are going to be uploaded. I should be getting 50-50 here. I obviously got some part that's not being detected correctly. Well, this is where that film strip really comes into play. So I'm going to go on through the film strip, and you see that there? That is actually a threaded part that the box is just off-center to where it needed to be. Now you can fix that job. You can fix that by just simply going over here, highlighting that, going back to select my areas to inspect, highlighting the outer edge of that sensor, and seeing the settings of that. We can move it just a little bit. How about elongating this box just a little bit to account for that variability? We can jump right back to the run mode, throw it back in the run, turn it on up, about where it needs to be. We're going to hit exit run mode and look at those images one more time. You see with the checker, you can save those images and it'll actually tell you what's wrong, unlike them traditional sensors. That one failed again. Now, good thing we have this film strip and we have the capability of taking care of this. Go back to run my job. See how easy it is to make quick changes? There we go. We got it fixed. Exactly 50-50. I'm going to hit exit run mode. Uploads my images again. Now we're going to go and illustrate the other trigger mode, free running mode. Go up to select my part, trigger, free running mode. Now in this mode, it gives you the ability not to use a part find sensor. So I can highlight the part find sensor and click delete, and the part find sensor goes away. Now it simply has the inspection sensor. I got to go back to live. It simply has the inspection sensor placed in a screen, and that's all it's doing is evaluating pretty much everything that's there. This is probably not a good application to do in free running mode, but in things that you're looking for just a hole or something like that, free running mode works just fine. Now you'll notice that as long as that sensor's, there's a thing, as long as that contrast is present in that box, the inspection's being carried on, and the output is being held high for that inspection. We're going to go over to the test my job to get back to that recording feature that I was talking about earlier. We have a drop-down menu here. Quite often when I go into a manufacturing facility to put in the checker, people tell me the production foreman says that I'm not allowed to shut a system down, and that's okay. With the checker, which we give you the ability to do is take a video. You only get 159 shots, but what we do is break it up into 3, 5, 10, and 30-second intervals. The checker can take 572 shots per second. So for this instance, I'm going to do video at production speed. I'm going to turn my turntable on to take images at 572 frames a second, as fast as it can go. And I'm going to remove this sensor before I do that. When I turn the turntable on, I click record, and it just took a little mini movie of those 572 images or shots per second. It only gave me 159, but it's taken that film strip for me. Now what you did is you took a little mini movie of the assembly line, and now you can go back and to a desk into an area and set the job up through the emulator. It's okay. I'm just going to give you a quick taste. I want to find this part. So I'm going to go back to select my trigger. I want to do an internal part trigger. I want to find my part. So I'm going to create a part find sensor. I'm going to highlight the top of this box here. Lower my search region just a little bit to account for some of that variability. And I'm going to go over to here real quick, grab a contrast sensor, place it on the threads, change to a rectangle, lower that down, put it on there, adjust the sensitivity, lower my threshold just a little bit, click it in the run, and run my job without actually using the turntable. Well, that's about it with the checker. There's not too many more. There's not too many things that you need to do to learn about the checker. That's pretty much it. You can email these film strips to somebody else. And the film strips and the job files are separate. So make sure if you're going to email somebody a film strip or a job file, that's done here under File. You can load film strip or save film strip. You can load image, save image. That's just one frame shot. And then the job file is done here. Open from Checker, so that would take a job file out of a Checker and put it on your PC. Open from a PC, so it would take it from your hard drive and open from the hard drive file and allow you to work with that job that you have saved for backup in case your checker gets destroyed for some reason. Save the checker as, that's going to allow you to save a job from your desktop to the PC, from your PC to the checker under a specific name, and I have that up right here. And this is saved to PC. You can save that job to PC, to place on your desktop. Now, what I set up here is just one job. This setup is considered one job. The Checker product will allow you to have and toggle between 16 different jobs like this. And this is the last thing that I'm going to show you. You can do that by going up to Checker, set up job control. No, I don't want to save this. And right here it says 0 through 15, 16 different jobs. Now right here, looks like job number 3. I think this is job number 3 is turntable, and job 0 is turntable. Now I have another plate that goes on my turntable here. And what we're going to do is we're going to throw this in the run, because the only way you can change job files is in run mode. I'm going to punch my little push button on there that loads the job file. It's 4 bits, 0 through 4, and a 5th bit needs to be toggled on the I/O module to change the jobs. That can be done with a rotary switch, or a thumb wheel, or a PLC. And I'm going to change my wheel on my turntable from threaded holes to some Vita packs for the pharmaceutical industry. And what I'm going to do is I'm going to make sure that there's a vitamin strip present and a label on these vitamin packs. Hit reset here. Exit run mode. And you see one of my vitamin packs. I'll go back to live to show you what it is. It's going to come in, it's going to detect the part, and it's doing an inspection. There's a strip present right here. I just want to see if that strip is present. And I'm going to go to the vitamin pack that doesn't have anything. And then I'm looking for this label to be present here. And this one has a strip present inside, but it doesn't have any label. So that's the Checker product, and I illustrated a job change and the free run mode, the outputs, and how to set the Checker. Are there any questions? Looks like a Mondo's. And Greg. Well, I think that's about it. I wish I could hear you, Mondo, but I can't. Thank you very much, and I hope this was insightful for you. And I will check. Okay, well, there's my contact information in case there's any questions offline, and feel free to call at any time. Checker's all I do, so I have a lot of experience in applications and other things like that. So thank you for listening, and have a great day.
The moderator has disconnected. At this time, the conference will be terminated. Thank you and goodbye.